So in this video, we're going to use the double angle and half angle formulas for cosine to get some values based on this given cosine value. So if cosine theta equals 3/5 and theta is known to be in quadrant 1, we need to know that because cosine theta being 3/5, it's possible theta is in quadrant 4, right? Because quadrant 4 and 1 will have similar cosine values, both positive. For equivalent angles in quadrant 1. So quick unit circle, these two positions being vertically aligned, right, will have the same cosine value. One's in quadrant 1, one's in quadrant 2. So we are going to be looking for cosine of 2 theta and cosine of theta over 2. Now for cosine 2 theta, I just pick any one of the three double angle formulas for cosine and just apply that. I don't need to worry about quadrants. That's handled by the formula. But for the half angle formula, because there's a plus minus in the formula, I do need to know which quadrant I'm working with. Okay, so let's see. Let's do the double angle formula first. That will be easier. And it doesn't matter which one I pick, really, but two of them require, the sine value. One requires both cosine and sine. Another requires sine value. Another requires only the cosine value. And since I only have cosine, that's what I want to deal with. So cosine of 2 theta, right? This is, according to the double angle formula, this is 2 cosine squared theta minus 1. So this is 2 times cosine squared, which that'll be 3/5 squared, so that's 9 over 25 minus 1. So this is 18 over 25 minus, 1, but I'm going to write that as 25 over 25. So I get negative 7 over 25. That is the value of cosine of 2 theta. Okay. So this, presumably this would mean we're in quadrant 2, right? Because it really could be 2 or 3. But if you think about it, if I draw a quick unit circle here, make it a little bit nicer, and and these are not perfect, but we'll call them close enough. So if cosine is 3/5, that's about 60%, it's like right here, so we're roughly like right there, right? So if you double that angle, right, that's going to put you, well, I'm a little surprised it isn't higher up. Maybe I haven't drawn it the best way. Basically, since we have a negative value, that means that the double angle is roughly here, right, in quadrant 2. Now, if we cut the angle in half, right, that means we're going to be like right here, still in quadrant 1. So I know cosine's going to be positive. So when I go to find the half angle, I know I'm still in quadrant 1. I'm not in quadrant 4 or whatever. Basically, if you start in quadrant 1 and you cut the angle in half, you're always going to be in quadrant 1 as a result. If you start out in quadrant 2 or 3, well, then it depends. You have to be a little bit more careful. Basically, draw it out and look at it. So now when I go to find cosine of theta over 2, I will say, well, I'll put plus minus now because it's part of the formula. So plus minus square root of 1 plus cosine theta over 2, right? But again, I know that I am in quadrant 1 still, so I'll just mark out that minus. We're not going to end up using that. So this equals the square root, the positive square root of 1 plus 3/5 over 2. Now, this is kind of messy because I have a root with a fraction inside of a fraction. It's a little messy. What I'm going to do to clean this up a little bit is I'm going to multiply inside the root and multiply the big fraction by 5 on top and bottom. And the reason for that is I want to basically cancel this denominator 5 here. When I do this, this 5 will multiply with the 1 to create a 5, and it will multiply with the 3/5 to create 3. 3/5 times 5 is just 3. So this will be the square root of 5 plus 3 over 10, right? So this is going to be the square root of 8 over 10. Or if we want the square root of 4 over 5. And we take this a little bit further. This is root 4 over root 5. Try that a little bit better. Well, There we go. Much nicer. So this is 2 over root 5. And that is the cosine of that half angle. So basically, this x-coordinate is 2 over root 5. Okay? So there we go. We found the double angle and the half angle using the formulas.